In today's video, we will see how to do a 3D trigonometric problem. So if you look at this question, we have a cuboid. What exactly does 3D trigonometry mean? When we are introduced to trigonometry first, we are told trigonometry is a branch wherein we deal with right angle triangles, that is 90 degree. The first theorem that comes to our mind when we talk about right angle triangle is Pythagoras. If it's the hypotenuse and you have other two sides, the square of the hypotenuse is sum of the square of the other two sides. This was restricted to just sides. Now what if we need angles? So when an angle comes into picture, we have sine theta is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is sine by cos, and so on. That being said, all that was on 2D figures, that is triangle. You identify the angle in question and accordingly you will have to figure out which ratio to use, sine, cos or tan. Now we have progressed to 3D shapes or solids. So which means this is a cuboid. Inside the cuboid there are so many triangles that you can see. We will have to figure out which particular triangle to use trigonometry on. That is why this is 3D trigonometry. Now, so if you look at the diagram, the width, the height is given, and AG, the line joining one of the top vertices to the opposite side, diagonally opposite side, bottom vertex is given. We need to calculate the angle between AG and the base. Now when it is angle between two lines, it's easy, but in 3D, one is a line, the other is a plane. EFGH is a plane. So obviously, you have to consider one line for the plane. Normally, for a plane, the diagonal is the reference for the base. So which means, let me use a light colored different shade and I'm putting, instead of dotted lines, this EG will serve to tell me which particular triangle I am analyzing. So now if you look at it, A, E, G, we have 5, we have 13. Now EG, the diagonal of the base, serves as the reference for the entire base. This is still 90 degrees in 3D trigonometry. When you are in 3D, other than X, Y, another plane Z also comes into picture. So now the angle between the line AG and the plane. So if you look at it, this angle is what is asked. Now observe, this angle is asked. We have the side opposite to it, we have the hypotenuse. So obviously sine is the ratio that should come. Sine theta is 5 by 13. Theta is sine inverse of 5 by 13. Now when you put it in the calculator or a clerk's table, so sine inverse of 5 divided by 13 gives us 22.619 approximately. 22.6 degrees you can say. So now if you look at it, all that was needed for this 3-mark problem was just sine theta's 5 by 13. So you might wonder why 3 marks. That is because you had to do all this analysis, and only if you actually figure out that EG is the diagonal base reference. Otherwise you would keep wondering and not know how to proceed at all. So because you identify the triangle correctly in 3D. That is why even this simple problem, as it might seem, is a typical IGCSE 3-mark question. So I hope that was helpful. I will see you all in another video. Thank you.